In this video, we're going to get started with creating the hearing ability for our enemies in the game. What we're going to start off by doing is we're going to go inside of our Puzz enemy information class, and we're going to create two variables, a variable float AI to hear distance and a variable bool B can hear. Now, each of these variables should really be set based on what type of enemy it is. I mean, some of them you may not want to use the hearing ability, and some of them you may want to hear further or shorter distances. But for the sake of this video, we're not going to be doing that. We're just going to be putting a set information that's going to be standard for all of our enemies. So we have AI hear distance equals 256, and B can hear is equal to true. Then what we do is we go inside of our Puzz AI controller class, and we scroll up to the top here. We're going to create two variables as well. We're going to create a variable vector heard location and a variable vector previously heard location. That's just used for our goals, and the previously heard location could just be used for later coding purposes. Then inside of our function initialize, down below after our switch, after we set our AI info, we do a check to make sure AI info is not equal to none, and if it's not, we also do a check to make sure the enemy can hear. If the enemy can hear, we set the hearing threshold, which is a variable created inside the pawn class, to the default value of the AI hear distance. If he cannot hear, we set the hearing threshold to 0, which means it pretty much can't hear, even though we won't be using any of the hearing abilities anyway for that situation. Then what we do is we scroll down to our wandering state, and we're going to create a function called hear noise. Now this function is actually an event, much like our C player function. So it's going to constantly be checked. And here we're just going to first we create a local variable called Puzz pawn called PuzzP, and then we do a super hear noise because we want to keep any code that exists in there. And then we set our PuzzP to the noise maker, because that's one of the things that gets carried in here is what's making the noise. We do a check that says if PuzzP is not equal to none and the Puzz player controller is the controller of the PuzzP is not equal to none, then we're going to check this, make sure if the heard location has been set yet. Vector 000 is pretty much the default if you haven't set anything in a vector. And if it hasn't been set, we're going to set the previous, or if it's not equal to 000, which means it has been set, we're going to set the previously heard location to that heard location of what it was, and then otherwise we're going to set the previously heard location to the noisemaker.location. Also, we're going to set the heard location equals to noisemaker.location as well, because that's really the main one we'll be using. And then we go to a state called check noise location. So we're going to scroll down to our new state called check noise location, and inside of there we start off with a function cplayer. And the reason why we do this is because what this creature is going to do is if he hears you walking nearby him, he's going to turn and try to find you. And if you're on the other side of a wall and he hears you on the other side of the wall, he's also going to go to that other side of the wall. He's going to pursue you on the other end. And if he sees you along the way, he's going to want to attack. It's not like he's going to want to go back to wandering or something like that. He's going to want to attack. So that's the purpose of why we use a cplayer here. We also use our check for blocking volumes function like we did before as well. Then under function bool find path to noise, we have another function. This is a lot, and decide moving path. This is a lot like our attacking state that we created. We return a true or false based off of find path. We set our two goals. We set our goal and our constraint, but this time instead of setting our goal to an actual actor, we're setting it to a location. And same thing with our constraint. Instead of constraining it to the actor we're looking for, we're constraining it to the location we're looking for. Both of them use heard location. And then of course decide moving path is pretty much the same, except we use heard location for our points, and we use a point reachable instead of an actor reachable for our if check. Then of course we also use the set next location and path function like always. And then we have the function hear noise again. And the reason for this is because if the AI is pursuing the player and trying to find where he was last, and the player moves, if he hears that player, we want to make sure that he changes his choice. We don't want him to just keep walking and not worry about the player. And that's the purpose of this, is to make sure that the hear noise gets activated and that the player or the AI actually changes his choice and where he's heading. What we also have in here is another function called check for new noise, which basically checks to see if the new noise is of a new location. Because if it is a new location, that's obviously we want the AI to pursue that new location, and we'll get to that function in a second. In the begin state, we had call on decide moving path right off the bat. And then, of course, down in here we have that function I just told you about, returns a true or false, which is a check for new noise. We pass the actor noisemaker in, and we just do a check to see if the new location of the noise is equal to the current location. Um, and if it is, then if we don't do anything, return false. But if it isn't, if it's a new location, then we set our new herd location, and we set previously herd location to herd location. Then we go back to the state check noise location, so we start all over again. So we go back to decide moving path, and we start all over again. Then inside of our begin label, we have a wait for landing, like always. We do it if pawn has reached its point, and if it has reached its point, we want to go to state wandering. Now you may ask, why would we do this? Well, obviously because if the creature's looking for the player because he heard him, and he gets there and the player's already long gone, well, at this point, what else would he do? I mean, he can't go to attacking because he can't see anything, and there's really no other noise because if it was another noise, he would have heard it. So he just goes to state wandering at that point. Otherwise, if he doesn't make his point reachable, then we pursue to the next goal. So as he's pursuing to each path to reach that goal point, along the way, if he sees the player, he goes to attacking. If he doesn't, he goes back to state wandering. And that pretty much creates our noise ability for our AI. Now this noise ability can be used for anything. It doesn't just have to be for walking. Um, if it could be used for a gunfire, it could be used for a particle system landing next to the creature. It could be used for many different things. And the way you create noise, the way this hear noise function picks up anything, is based off of a function called make noise, which is located inside the actor class. Inside of our puzz pawn, we're actually going to tell it to make this noise. What we're going to do is we're going to grab event set walking, we're going to keep the current code that's in there, and we're just going to type in make noise 1.0. What that means is that when the player is walking, it's going to register the hearing threshold at 100% of its value. So that 256 that we set, that means that when the player is walking around the AI, its radius is 256. Now, if you set this lower than 1.0, then obviously that means that the player is creating less noise, and that it'll decrease the hearing threshold when it gets checked. So if you do like 0.5, for instance, that would probably load the AI's hearing ability down to about 128, so it won't hear as well. And that's kind of the idea of, if you created like a sneak ability, you could actually not make it create a make noise, or if you wanted to, when the player, for instance, holds the shift button, which makes him walk, you can make the walk make less noise because he's not moving as fast. But either way, however you want to program it, it's up to you. But for right now, we're just going to make noise every moment when the player's walking at a 1.0. And that really gets everything going. So at this point, if you were to start the game up, the AI would respond properly to the making noise ability, and would pursue you if he saw you, and would go back to wandering if he didn't.